In this video, I'm going to create a microwave link between an onshore transmitter and an over-the-horizon receiver. My current radio settings are a frequency of 1.2 GHz, transit power of 2 watts, and a high directional antenna. I'm currently using meters above sea level, hence my current height is set at 8 meters to be at 2 meters above ground level of the transmitter. I'm going to use the path tool to check my current RSSI at the receiver. I can see from the graph the curvature of the Earth is playing into effect due to the distance required for this link, with line of sight and the Fresnel Zone being significantly impeded. I'm now going to save my settings as a template and then export this as a JSON file. This can allow me to use the Path API, which includes a number of features in the output, which can help me to create a suitable link. I've now created a request in Postman using the local host address of my SOOTHSAYER server and using the template downloaded as a body. Sending this request to the API gives back a number of parameters already visible in the path profile graph. What's also included is a number of outputs which are quite important, such as the height to achieve line of sight, as well as full Fresnel zone. With my current settings, I can see that I need to increase the height of my transmitter to achieve line of sight. Even by using a 20-meter mast, I still need to increase the height due to line of sight in the Fresnel zone being impeded. Having exhausted available hardware to create this link, I'm now going to look at alternative positions to place a transmitter. One thing about using meters above sea level is that you will need to constantly update the height to suit the environment. An error message will appear indicating the height required to be above ground. With this new location, I can see that I have now achieved line of sight to the receiver. However, the Fresnel zone is still impeded by the curvature of the Earth. One way to reduce the size of the Fresnel zone is to increase the frequency of the signal being transmitted. Even when changing to a higher signal, 4.1 GHz, the Fresnel zone is still hitting the Earth, which will cause disruption to the signal. I've now updated my API request with a new lat and long of my transmission site. However, the responses still show that I need to increase the height of the transmitter significantly. Even when assessing the link with higher and higher frequencies, the Fresnel zone is still impeded. I'm now using the map to find a transmission site with higher altitude. I'm using the cursor so that I can identify the bearing from the transmitter to the receiver, so I can correctly set the azimuth of my antenna. I'm then going to use the path profile tool to again check the RSSI at the receiver for my current settings. Using 2.4 GHz, I can see that I have line of sight and the Fresnel Zone is impeded. I can also test higher frequencies using the PPA tool and see that they offer a greater gap between the curvature of the Earth and the Fresnel Zone. This might be a more suitable option, seeing as the ship is in a fixed location.